In problem number 10, we've got set A. It's got 10 digits. Think of these as like cards with numbers on them, or dice with this many sides. Anyway, set A has got these digits, and then set B has got these digits. So what we're going to do is we're going to write out a possibilities table. Set A has got 10, and that looks like 6 zeros going across, and then 3 2s, and then a 4. And then set B has got 7 digits, and it's going to have 0, 0, 0, 0, and then 2, 2, and then 2. And then what happens is that X is the sum of these numbers. And so all we've got to do now is add these up. And your first inclination is, this is ridiculous. All I'm doing is writing the same thing over and over again. And what they're trying to do is set up a situation where you obviously have a pretty extensive possibility table, but the adding of the numbers shouldn't be a big complication. You just got to make sure you're careful and that you don't screw it up. We've got 10 and 7, so that means we're going to have a total of 70 numbers in our little grid here. And see, now we can go and figure out the probability that X is equal to 2. Well, one way to do that is to count up all the 2's. You'll see that there are, let's see, 18 down here, and then 12 up there. That's 30 altogether. So then that's 30 out of 70. We've got 30 number 2's, and we've got 70 numbers altogether. And so we would divide that, and we'd find the probability is 3 over 7. Now, the other way to go about that is you could use actual probabilities. The probability of X equaling 2, well, one way for that to happen is to get a 0 and a 2 together. And that's got a 3 over 7 possibility times a 210 possibility. And then the other possibility is that I could get a 2 and then a 0. And I can do those probabilities and multiply them together. And when I add those, I'm going to get 30 over 70, just like I did a second ago. And that's going to equal 3 over 7. Now, in number 2, it says put together a probability distribution of X. Well, this is going to be pretty easy. We don't have that many values for X. 0, 2, 4, and 6. And the probabilities we've already figured out. 1, we can just do the zeros. Let's see, that's going to be 4 times 6, 24. Or I'm sorry, plus 24 out of 70. And then 2's, we already know there's 30 out of 70 for those. And the 4's, we've got 13 out of 70. And then the 6's, there are only 3 of those. That's 3 out of 70. That's our probability distribution table. 24 plus 30 plus 13 plus 3 is equal to 70. We're looking good. Now they want to find the expected value of X. And so that's a sum of all the X's times our probabilities. All I do is write this out and then type it in the calculator. And I'm going to find out that the expected value for X is going to be 13 over 7. And then they want me to find the variance, and the variance is going to be the sum of the X squares times their P's. And I'm just going to go ahead and change the numbers that were in front of the fractions into their squares, and go back into my calculator and put that in there, and then minus 13 over 7 squared. And I'm going to find out that that is going to be 681 over 245. And that we can do that to decimal 2.7795 or 2.78, 3 string of figures. Part 4, it says given that X is equal to 2, find the probability that the digit is chosen from set A. Well, so we can see all the scores right now. In our table, we can go ahead and write those. Okay, these are the 2's, and then there's also these 2's over here. So altogether we have 30 2's, and let's see, looks like 12 of them occur when set A comes up with a 2. So 12 out of the 30, that's going to be our probability, and that's going to reduce to 2 over 5. And that's the answer to part 4. All right, let's look at the next one. In number 14, we've got a box. It's got 2 green apples and 2 red apples. And the apples are taken from the box one at a time without replacement. The process stops once we removed 2 red apples. All right, X is the number of apples that have been taken out once the process stops. So I'm going to use a tree diagram for this. We'll start off with our first pull. It could be either a green or a red, and it's going to be 2/4 and 2/4 for our probabilities. After I've pulled one green, I still have the possibility of getting one green and one red, and then getting another green, another red, after first pulling a red. All right, so now, after the two greens, well, the only thing that possibly can happen is I get a red and then a red. Those probabilities are both ones. If I've pulled a green and then a red, well, I still could get a green or a red, so I'm going to make those branches, green and red. And that probability will be 1/2 and 1/2. There's one each left of each. After the green, well, there's only one thing left, a red, and the process stops because there's two reds. All right, so let's fill in this. This is 1/3 and this is 2/3. All right, so now let's go back over here. Here we pulled out one red, so that means there's 2/3 green and 1/3 red. The process is going to stop after the second red, so there's no more branches on that one. Keep in mind, like I said, no matter what, the process stops after the two reds. So anytime we get there, that's not going to go any further. Now this last, we've got a red and then a green, so it could be either green or red. So let's go ahead and put that down. And again, that's a 1/2 and a 1/2. After a red and a green, well, the next thing, the only thing can happen is a red. And see, now my tree is done because I've got two reds in every branch. So let's map this out. This is green, green, red, red. And the probability of that happening is 2/4 times 1/3 times 1 times 1, which we could leave out. And so that's going to give us a probability of 2/12. And then our next one is going to be green, red, where the probability is going to be 2/4 times 2/3 times 1/2 times 1, which is going to give us 4/24. And then this one here, that's a green and a red, and that's going to be 2/4 times 2/3 times 1/2, which is going to give us 4/24. And then the next one, that's going to be red, green, red, and that's going to be 2/4 times 2/3 times 1/2 times 1, and that's going to give us 4/24. And then this next one is going to be red, green, red, and that's going to be 2/4 times 2/3 times 1/2, and then that's going to give us 4/24. And the last one is if I just get two reds, the whole process stops, and so I have 2/4 times 1/3, and that probability is going to be 4/24. Now keep in mind, X is the number of apples we've drawn, so we should indicate that. And I'm going to go ahead and change this to a 4/24, and this to a 4/24, since everything else seems to be out of 24. So let's see, there were 4 apples drawn here, 4 drawn here, 3 drawn here, 4, 3, and then 2. So these are our possible X's for our probability distribution. And the part 1, they want to know the probability that X is equal to 3. Well, all I've got to do is add up these probabilities next to these 3's. That's going to be 4/24 plus 4/24. That's going to be 8/24 or 1/3. That's the probability of X equaling 3. And then they want us to draw a probability distribution table. And all I've got to do now is take a look. I've got my numbers, my X's, could be 2 or 3 or 4. I already know the probability of 3. We just figured that out. That's going to be 8/24. And see, let's see, 2, that only happened once. That's 4/24. The 4s, that happened 1, 2, 3. That's going to be 12/24. And there's our probability distribution. And let's see, part 3. Okay, now you'll notice how we've got this paragraph, there's new words here. Basically, we're telling you is, okay, forget everything. This is a new problem. It doesn't have anything to do with the stuff before it. So let's write this in red. Another box has got 2 yellow peppers and 5 orange peppers. I'm going to say R for orange. I don't want to write O. And 3 peppers are taken from the box without replacement. Now, given that at least 2 of the peppers taken in the box are orange, find the probability that all 3 peppers are orange. So find the probability that 3 are R when at least 2 of them are R. Well, the nice thing is, well, the way this both happens is it has to be 3 oranges, because then there will be at least 2 and 3. And then we're going to divide by the probability that there are at least 2 orange. Alright, so let's first find the probability that there are 3 orange. That's 5 choose 3 times 2 choose 0, all divided by 7 choose 3. That's going to give me the probability of choosing 3 orange. And then if I want to divide by at least, 2, well, then that's going to be 5 choose 2 times 2 choose 1. That's going to be at least 2. And then the other one is going to be 5 choose 3 times 2 choose 0, because that's going to be at least 2. That's going to give me 2 sevenths over 6 sevenths, which is going to be 2 sixths or 1/3. And then that's the answer to this question. All right, hope that helped. Let's look at the next one. In this problem, we've got a probability distribution where the random variable x takes a value of 120 over r, and the probability is r over 45. And then the r's can be 1 through 9, including 1 and 9. All right, so let's break this out. X's can be 120 over r, and the probabilities can be r over 45. All right, don't let that whack you out, because all we know the r's is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now in part 1, it says, show that the probability that x is equal to 40 is going to equal 1 over 15. So we're going to use this formula they gave us. X is equal to 120 over r. And we know that x is equal to 40, so we can substitute in the 40 for the x. All we got to do now is get the r by itself. We find out that r is equal to 3 when x equals 40. And so now all I got to do is find my probability. Well, the probability is r over 45, r equals 3, so the probability is going to be 1 over 15. Now for part 2, they want us to construct a probability distribution table for x, and so we're going to need to know our x's, and we figure those out by doing 120 divided by r, and r is 1 through 9. So 120 divided by 1, 120 divided by 2, 120 divided by 3, all the way up to 120 divided by 9. So x is going to be 120, and then 60, and then 40, and then 30, and then 24, and then 20, and then 120 divided by 7, because that didn't come out very nice, and then 15, and then 40 over 3. And then our probabilities for each one, well, that's just going to be r over 45. And we know the r's, and if I'm going to put them right above here, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Well, so the probability is going to be 1 over 45, and then 2 over 45, and then 3 over 45, 4 over 45, 5 over 45, 6 over 45, 7 over 45, 8 over 45, 9 over 45. Yes. Does 1, 2, 3, 4, 5, 6, 7, 8, 9 all added together equal 45? We'll check and see. Number 3, the modal value for x. Well, that's going to be the x with the highest probability. And in this case, the highest probability is going to be 9 over 45. So that means the x that matches up with that is going to be 40 over 3. And that's going to be the modal value for x. And then the last one, it says find the probability for part 4 of x that lies between 18 and 100. So all I've got to do is find the x's that are between 18 and 100. And let's see, we got 20, that's between 18 and 100. And 24 is between 18 and 100. And 30 and 40 and 60, those are the ones that are between 18 and 100. And now all I've got to do is add up those probabilities. And I'm going to find out that the probability is going to be 20 over 45, or 4/9. All right, hope that helped. Thanks for watching.